Hello there. Good evening. I'm doing kind of an experiment tonight. Oh, cool. This is purely an experiment. I'll get to it in a moment. But let me find all my chats. Okay. Hello, old geezer. Good morning. Or good evening. Hello, Aiden. Welcome. Thanks for joining. Hello, Cosmic Ray. Yep, don't forget to like the stream. Hello, Jeff. And hello, Turf. And for something completely different, I'm trying to see if, unfortunately, I can't bring the chat on stream, but I'm actually streaming to YouTube Shorts, vertical, pure experiment. But thanks for those who are joining on the YouTube Shorts side. Don't forget to give the video a like. I'm going to be going through some kind of the theme tonight. I tried this a few days ago, but it is across the universe. This is on the YouTube short side. Basically, I'm going to be doing some live observing with telescopes, and I'm multi-streaming to Twitch, YouTube Shorts, and YouTube. Yeah, don't cross the streams. Hello, cheap ass operator. Yes, banana time. This is on YouTube Shorts. I did succeed. I'm seeing chat from YouTube Shorts. Nobody on Twitch right now. Yeah, nobody on Twitch, but I'm seeing there's people on YouTube Shorts. I'm seeing it all. So I'm not going to just keep talking about that. I am going to move on to getting the scopes ready. First, which one am I going to go to? Let's go over here. All right. It's a blank screen. It will not be blank for long. Give me a moment here. I had been kind of getting this one set up, which is actually kind of dull. So let me see, which one can I bring up first? Let me bring up the browser here, and I'll move this one off screen. And okay, nope, wrong window. Okay, so we're going to bring up the scope at Starfront Remote Observatory. It's a pretty dark night, but unfortunately the moon is quite bright, but we'll get that scope going in a moment here. And hopefully it won't have issues tonight. If not, I've got 2 other scopes while I figure that out. So I'm just gonna try. So one thing that I'm kind of experimenting with is the canvas for the canvas for the YouTube Shorts. Hold on a second. Because it's most of it's off screen, so Please bear with me while I get it on screen here. Yeah, banana time. It's I'm just getting it set up and don't have to worry about the details of it. But where's the 6 hours short? Yep, exactly. Get the start of stream before. Oh, hey, welcome, Seiko. Good evening. And where's the Calliope music? Yeah. So that's a question I have for you, Banana Time. Can you? I mean the. Oh, sorry. Let me. So this is a brand new layout, so you'll have to bear with me. The overlay for the chat is a little off, but otherwise, can you hear me fine? Yeah, so as far as what am I doing here, I'm trying to get some scopes going. You can see the telescope right here. That's a camera looking straight up, telescopes on the left, and the bright thing is the moon right now. This telescope's located in Texas. I am as well, but this is a few hundred miles away from me at a darker location. And you think you're going to I'm going to combine the Earth with a black hole? Hopefully not today. But let's get this going. Oops. And I'll just hit start here, and it should start getting set up. Good evening, qubits. Oh, hi, Wiley Sight. Are you on the right stream? Because there's 2 streams right now, which is probably not ideal. This is the short stream. Okay, thanks, Duolingo. Duolingo CEO, thanks for stopping by. So the telescope should be getting lined up. Yeah, the problem is it just got dark here, dark enough to get the telescopes going. So let me see how that's going. The one at Starfront. Let's hope it's not. Okay. Okay. It was able to plate solve, which is encouraging. Which is very encouraging. All right, so it's getting itself ready. Meanwhile, I have 2 other telescopes going here. One is a Seestar S50, and the other is a refractor, which if you're on the Twitch or YouTube feed, you can see it below me. Yeah, cool. So you can see we've got the controls for this scope here, and yeah, it's unfortunate because ideally I'd like to yeah, what short street for short people. No, it's it's YouTube Shorts, and they actually let you stream to YouTube Shorts, which is kind of interesting because Shorts historically were limited to 1 minute, but then they extended it to like a few minutes, but you could stream for like hours on a short, which is interesting. Yeah, that might be something I need to work out the details on, because I want to do the short stream, but the problem is if it's gonna cause issues, I will have to make some adjustments. But that's okay. This was all experimental, so I'm like layering levels of experimentalness, which probably isn't always the best idea. But so the good news is the scope looks like, yeah, it looks like it did its polar alignment. And yeah, so we should be good to go on that. Yeah, now let's not. Why do you have to stream to 48 places? Because my life isn't complicated enough, I guess. Anyway, so the theme of tonight's. Oh, hello, RW. Good evening. I'm about to get. Yeah, I'll work fine even after not working at all remote. Well, that's good. Yeah, hello, hello, RW. So tonight's theme, which I tried to do previous nights and didn't work, was hold on a second. Just I might end up overcomplicating things to the point where I'm just a big mess. But yeah, so tonight we tried this a few nights ago, and it ended because of weather and some technical issues delayed it. But I have 3 scopes across 2 locations, and hopefully things will go more smoothly. The goal is to go through a bit over a dozen targets, dozen different astronomical objects, starting from things in our cosmic backyard to some of the most distant things in the universe. And as we go, I'll try to remember to mention like how far away it is and what that means as far as what we're seeing. So let's get to it. The first thing I'm going to start with, unfortunately the little checklist I have doesn't show up on the short stream, but basically the first objects we're going to try or look at are in the solar system. And like I say, if you tuned in last time, you may have seen some of this. We want images. Exactly. And images you shall have. So let's go to live view. And we're going to start with perhaps an uninteresting target. Well, right now it's just pointed at some random stars. But what we're going to do is I'm doing this off camera. I am going to go actually no, don't want to do that. So what I'm going to do is stop this and we'll see if this works. And again, there's method to my madness. And like I say, unfortunately, if you tuned in last time, some of this will some of the same objects. Or maybe it won't. Maybe I'll mix it up a bit. Okay. Is it actually... Did it actually do anything? Maybe it didn't. Is it actually slewing to the target? Yeah. Bright almost feel the rainy day. Yeah, exactly. We're being mooned. Happy Star Wars Day. Oh, hey, yeah. So let's see. Interesting. Oh, I think it's just searching for it. I think I see what happened. Okay. Okay, yeah, okay, and search, and okay, we'll get there. All right, so it's starting to go. Sorry. Starfront. It's the it's ALP, which is the kind of the web interface. Yeah. SANAF. Yeah. Yeah. Thanks, Chief S. Ham operator. Okay. Okay, let me stop this because, yeah, this is always a hard one when I'm doing it remotely because the S30, yeah, there we go. See, the S30 sometimes Turf has the mood on Discord. Well, I have it now too. So I'm I'll get there in a moment. And I've the problem is the way I have things set up right now. It's a little kind of, I might not be able to easily what in the world? I might not be able to easily bring that up on stream today, but we'll try that in a moment. Okay. So did that do anything? Is it even updating? Well, I might go ahead and bring it up on bring up Turf's actually that's fine. I say it's going to be tricky, but I forgot a little detail. So this is this is the moon, courtesy of Turf, who's on our Discord server. If let me drop that in here. Sorry, I'm juggling some stuff here. Okay. And yeah, so there is a Discord server that Turf is sharing the moon on. But basically the reason I wanted to start with the moon is it's the closest thing to our the closest celestial object to Earth. There's humans have set foot on it, have orbited. We've sent many probes. It's been part of legend and religion for millennia. Yeah. No comment on that. But I wanted to start with this because this is the closest thing and the only thing that humans have actually been to. We're able to see things throughout the visible universe, but we ourselves have only made it to the moon. It's about not quite 250,000 miles away, 240,000 miles. So a bit over a light second away. So it's not, have a good look. We're not going back there anytime soon with NASA cuts. Yeah, I mean, it's, oh, hey. Oh, hello, GZ and Hot Cheeto over on Shorts. And hello, Quantum. Don't forget to like the short video, and don't forget to like the normal video if you haven't already. It does help these live streams. How many viewers really care about the moon? I do. So one of the things that I'm going to do after this live stream, and I've been trying to do more, is put all the images I take during the live stream out on my website. So I'll update the description after that. Just wanted to put that little plug out there. So now we've looked at the moon, and it's time to move on to something a little farther away. So let us go to let me go to stop this, and all right, we're gonna go to if we're lucky, we're gonna go to the red planet. So, of the 8 planets, including Earth, Venus and Mars are the ones that tend to be closest. And so Venus isn't in a position where I can image it, so we're going to look at Mars. Is that Mars? Oh, that's weird. It's doing the dark library again. So it's having to re-initialize itself. So Give me a moment here. Is this going to be the final exam? There will be a quiz at the end. Centaurus A is pretty. It is pretty. Yeah, the fourth rock from the sun. Exactly. That's what we're looking at. And once the dark library is done, hey Benji, I see you on the short stream. So if you're on the short stream, there is a wide aspect stream. I'm streaming twice to YouTube, which, funny enough, it allows you to do on one channel. You can stream twice. Of course, watch this just totally wreck retention and stuff. Anyway, it's running an autofocus right now. You can see it right here. And hopefully it'll sort it out and we can be on our way. We can start seeing the fourth rock. Yeah, unfortunately, like I say, if you're on the short stream, you don't see it, but on the other streams, you can see how bright the moon is tonight, just blasting down on things. And so in a way, it's a good all of these subjects we won't dwell on them too long, and they're all fairly bright. Just looking at yeah. Okay. All right. So it is want exoplanets. Yeah. Oh, you're yeah. How's everybody doing? I'm doing fine. How are you? Thanks for joining Hot Cheeto. Okay, so for whatever reason, this did not. Again, Alp has been causing. I guess I only had it go for a few minutes and it burned through all the time with calibration. But yeah, so what we're looking at here, I guess it's near enough to the moon. It's kind of washed out a bit, but this is Mars. It's kind of tiny in the frame. But that is with finger paint tonight. So that is Mars. Good, great. So let's see. I'm expecting more stars in this image, but maybe it's just burned out from or overexposed from the moon. Let me check. Yeah, I guess it's actually, let's look. The Mars is, yeah, well, it's amazing we're actually able to image it at all. If you look, Mars is really close to the moon. Extremely close, which is why it's all kind of washed out, but normally it would look kind of red. So, yeah, so, when does Astro 677 start? So, GZ, unfortunately, yeah, with the telescopes I've got, going right now, I can't get any closer of an image to Mars. Let's see. Yeah. Now, when I do get a chance and I'm using the right telescope, I can get a fairly good image of Mars. Like this is one I took with another telescope a few weeks ago. Actually, it was in January of Mars. So this was taken from the backyard, but it's not a live view. But that's what it looks like. You've got the polar cap, which is a combination of water ice and carbon dioxide ice, dry ice, and different geologic features. But yeah, so that's as close as we can get. Yeah, thanks, GC. So we're gonna move on now. So Mars is about 100 million miles away from Earth right now. Actually, a little bit further. So it's further than, it's more than an astronomical unit. So more than the distance from Earth to the Sun right now. So so light takes like a few minutes, 8 minutes or so, to get from there to here. Now, the next thing, which I did image last time, but I think it's still worth looking at again, is one thing I've been doing recently is imaging some asteroids. And last time I did one of the brightest asteroids, which is in the main belt. It's a few hundred miles in diameter. Yeah, I mean, so Mars is, I do believe eventually we should send people there. I think a lot of people greatly underestimate how challenging it'll be for the people who end up there. Unless we can do a lot with automation to get stuff there. But people will be so, I guess if you like read stories about how people deal with being in Antarctica at bases for like, you know, for months at a time, how my favorite Mars or my favorite Antarctica, it's there's a lot of psychological stress of being isolated away from people and not being able to leave. And I remember reading this story about this researcher who I guess had been messing with another one and kept ruining the endings of books that the person was reading, and the one person whose books were getting ruined stabbed the other person. So yeah, I think so. I mean, the thing, even with Antarctica, you can still get people back within a few months or sooner if it's a big, I mean, depending on which base it is and stuff. Mars, there's nothing. And, you know, at least in Antarctica, you have a lot of water ice around. You have a breathable atmosphere. I think it's going to be really hard on Mars. Yeah, happy littles. So the Mars was taken with my Cassegrain, not a Schmidt-Cassegrain, but a Cassegrain, and it's Yeah, and so and I was using live stacking with that. I didn't do any processing after the fact. I was just using sharp caps, live stacking and sharpening. Sounds like setting up a one-way penal colony. Yeah, which has been done. Humans have done that, but I don't. Yeah, it would be rough. Yeah. And yeah, GZ, the lack of tech food, people might go insane, no way back. Yeah, I mean, it's going to be hard, which is why I think, like I say, I think going right to Mars is premature. I think the moon is a good first target because, like, if things go badly, you can get back to Earth pretty quickly. Like we found out with Apollo 13, something went horribly wrong. They were able to swing around the moon and get back. It's so you can actually have conversations with people, like phone calls with them, because the light delay isn't that much. Whereas with 8 minutes, it's more like, you know, sending the person videos or emails or something, and then waiting for a response back. There's no back and forth. So I think, and then plus there's no, I guess my other thing of why I think it's premature is what happens if we find like subsurface bacterial life? Are we just gonna, you know, because like up until now, a lot of the landers, as far as I know, have all been sterilized. So in case there is life there, we don't contaminate it. Similarly, like the space probes around Jupiter, the Galileo probe, they crashed it into Jupiter so it wouldn't accidentally run into Europa in case Europa had life. So I'm like, what happens if like we haven't, it's an unanswered question. Like, so to have all these plans around Mars with this unanswered question about like, is there life there? I feel, I don't know. Whereas the moon, I think, pretty much guaranteed no life there. Combination of hard vacuum and really bad high temperatures. And if it is, it's a good chance some of it might be contamination from Earth, from stuff getting blasted off. So this bright star right here, I digress a bit. So this bright star in the middle here is actually an asteroid. It's Vesta, which was the fourth asteroid to be discovered in the 1800s. But what I find interesting about it, and I guess I didn't realize it is bright enough that it, from a dark sky, you can see you can see it with the naked eye. So theoretically, people had seen this in the past. They may have thought it was a faint star, but it was moving very slowly. It takes like 2 or 3 years to orbit the sun. But yeah, it's like 5 point something magnitude. So not visible from where I am in Houston, but definitely would be visible elsewhere. So this one's about 300 miles wide, or no, 300 kilometers, I think. And it's in the asteroid belt. Yeah, exactly. 75. Yeah, death sentence. We don't have enough regolith here. I mean, I think, and that, yeah, I mean, I guess I agree, yeah. Yeah, well, there you go. I mean, we haven't even quite worked out the low Earth orbit stuff. Yeah, exactly. We can't even manage safe flight inside the atmosphere. Yeah, exactly. Yeah. Yeah. There's gotta be well, yeah, there's that whole thing about the whatever line. But anyway, so that was the third target. So this is that Vesta is actually slightly closer to Earth than Mars is. Mars is actually right now about 132 million miles away, whereas Vesta is about 110 million miles away. Now, one thing I didn't mention is from the moon to Mars, or Vesta, we had about a 400 or 500 fold jump in distance. So I'll go back to that in a bit. So now, okay, cool. I have to sort out some things here, but I'll try to drag that in, pull that in. So now we've got the last thing in. I had debated doing Jupiter, but in the interest, we might circle back to Jupiter. But I had tried a target last time, and the scope was having so many issues that I ended up not being able to image it. So let's, hopefully today things have been working better. Let me just see where that is. Okay, it's high enough in the sky, I think. Make sure the time is right. Yep. All right. So next, we're going to another asteroid, which I tried to image last time, but it didn't. I think I ended up having some technical issues with it. I'm going to go to Haumea, which is an asteroid that is. It's not an asteroid. It's classified as a dwarf planet, and it's objects like Haumea that is one of the reasons why Pluto was demoted from being a planet to being a dwarf planet, because Pluto was discovered in the 30s, but then astronomers started finding these other objects that are out past Pluto, trans-Neptunian objects. And some of them are bigger than most asteroids. Like Haumea is, I think, over 1,000 kilometers wide, and it has a couple of moons. Now and what's interesting is it's bright enough we can image it with the Seestar, but yet it wasn't formally identified until the early 2000s. They went back then and looked at other plates, other images, and found that it had showed up going back in astrophotographs back into the 50s, but it wasn't until 2004 that it was identified. So we're going to try to figure out where Haumea is in this image. So let's bring in. So if you look, Haumea would be, if you see these three stars here, and then there's a bright star. So let's move this off to the side. Oops, totally messed that up. Problem is I'm trying to do it off screen and didn't work. Okay, so here's the three stars, and there's the bright star. And now one of the reasons to image Haumea right now is it is at opposition to the sun, so it's like opposite in this, or as far away from the sun in our sky as it normally is, about 2 weeks ago. And but as far as the distance goes, it doesn't make a drastic difference. Haumea is right now it is about 5. Wait. Yeah, it's a bit over 5 billion kilometers away from the sun, so over 3 billion miles from the sun. Or right now it's 34 astronomical units from the sun, which is the 34 times the distance the Earth is from the sun. And then comparing that to Neptune gets is less than 30 billion or less than 30 astronomical units. So this is further from the sun than Neptune at the moment, and it's going to get even further from because it's got a kind of elliptical orbit. How much velocity does he gain? Not as much as when a cow belches. Simple rocket equation after that. Hello, AstroCop. Losing my astronomical darkness in a month. Oh man, you must be far north. Vesta, which we brought from a mineral show. Interesting. So here is, so let's look at sorry, I'm trying to, there we go. So you've got this. Okay, this star is like a double star, and then you've got this. Oh wait, looking at star patterns to try to figure out where Haumea is. Let's zoom in a bit. Oh, Joe V, you may have clicked on the YouTube short video. I'm streaming both wide with I'm streaming both landscape and portrait today, and clearly I need to make that a little bit more obvious. So let's reset. Okay, so I kind of got actually, so let me reset and then we'll zoom in with this, because the reason I'm spending time on this is I want to make a point of pointing at the right thing, because otherwise yeah, okay, so there's the double star, and yeah, so you've got this pattern of stars here, and I think know how well that shows up on the stream. But this little dot here, let me make sure I'm should be a really bright star down there. Okay. Problem is sometimes the star maps are different frequencies, so they end up. Okay, yeah. I believe let's see. Wait, am I rotated a bit? Oh, wait a second. Sorry, it's part of it is my own wanting to make sure that I am actually looking at it. So we've got that. Oh, you know what helps? I have it. Okay. I had it. Of course, it ended just as I was. Let me start it up again. Oh, hello, Joe V. Great. I'm glad you were able to get that out there. It's been a while. Good to see you. All right, so yeah, the problem was I had the the image was that I was looking at in Stellarium was based on equatorial, or not equatorial, on alt azimuth, and so it was like all rotated. Okay, so we're back. All right, so okay, those two stars, and then okay, those two. And then, okay, these two, and then there's a star there, star there, star there. It would be somewhere in somewhere in here. a star and that's a star. And all right. Give me, I'm almost there. Oh, wait. Yeah. Okay, so that star is 15th magnitude. So let's see if we can zoom any more in here. I think it would be somewhere. I need that enhance button. It's one of these, I think, that are just faint fuzzies. Yeah. Yeah, okay. So that star there is about 17th magnitude. So Haumea would probably be around here. So I think it's starting to show up. I'm sure with pushing it, I could get it, but basically I have image things at this brightness, so pretty sure it's somewhere. Maybe it's one of these. Yeah, I might have to, or it could even be. I don't think it's this one. I think it's starting to come through around here or here in the noise. Anyway, Haumea, which, like I say, is further than Neptune. Yeah, it's I've imaged things down to the 17th magnitude, so imaging we had to drive for 12 miles. 4 nights in Bortle 2, yeah, cool. Still a few weeks. Yeah, so what I'm looking for is it's an asteroid or a dwarf planet Haumea that is further from the sun than Neptune. Oh wow, that's amazing. But yeah, somewhere in here, Might be one of these. But I think the moon isn't helping matters. But yeah, it's in there. And I have a feeling that if it hadn't ended, I would have, it would be more apparent at this point. Anyway. Yeah. So. Haumea. Let's see what. Let me reset the zoom here. And we will move on. Been imaging in the solar system, but now we're going to move on. So, Haumea was a 30-fold jump in distance versus Vesta. So, or more than 30 or 40 times, 30 times jump in distance from the sun, or distance from us. So now we're going to go, and again, this was something that was imaged previously. Oh, yeah. This happened again. This happened before. All right. Haven't installed Discord. Yeah. It's for me, it's on machines where I haven't installed it recently. It's always a pain when it ends up loading or having to apply updates for several minutes. Okay. So this one's pretty easy, but let me bring something up that I had meant to bring up earlier. Oh, can I even bring this up? All right. So what hold on a second. I'm loading something in the background that I'm going to bring on screen. But unfortunately not on the short thing because I haven't gotten the overlay set up right for that, but it'll only be brief. What are the other two scopes doing? I think I was just trying to get everything running that I kind of have neglected them. So I'll take care of that soon. Thanks for reminding me. Hopefully this doesn't. Yeah, this might be a bad idea. Basically, I've been playing around with Space Engine, and I was gonna do some extra visual aid there. But anyway, this one doesn't require a ton of time. But this little red star here is Wolf 359, which is the third closest star to the sun, or to the solar system after the. It's the third closest to the solar system, besides the Proxima Centauri system. So there's actually more than one star in that, and Barnard star, and then Wolf 359. It's a red dwarf. It is pretty small, and it's not super bright. But it is one of the closest stars, about 7 light years away. So we're seeing it the way it was 7 years ago. But this jump we just made was a from Haumea to this one was a 10,000-fold jump in distance. So yeah, it's quite the thing, quite a distance. But it's a star, so we saw it. Now we can move on to the next target, which is let's see. All right. And while I'm waiting for that to get going, I will do something with the other scopes. Oh, that's why. All right. Oh, good evening, Brent. Welcome. Thanks for joining. Quick and dirty Iris Nebula. Let me bring that up. So this is Aiden's Iris Nebula photo. That's really cool. Barnard star is the third closest. I guess it depends if you're counting. I think it's the third. Is it Wolf 359? I guess if you lump. Yeah, Alpha Centauri system. And then there's Barnard star, and then there's. So I guess, so if you lump Barnard's, so if you count each star in Alpha Centauri separately, which they are separate stars, I just kind of lumped them together as part of the same system. There's also 2 brown dwarfs that are closer, but those aren't full stars. So I kind of ignored those. Oh, nice. Our own M81. Nice. So, I like the iris there. Alright, so what is going on? We're just dropping frames. Spectacular. I wonder, where is M1? Oh, it's really low, unfortunately. Well, although it's interesting because it did plate solve and it has gotten one image, one frame. But basically, if I could just get another one, I think it's off center there. But basically I went to Messier 1, the Crab Nebula, and the reason I picked that as the next target, which again, so this one is another 1,000-fold jump from Wolf 359, and so it's like 6,500 light years away, and the Crab Nebula is the remnant of a supernova that was witnessed in 1054, and I guess it was in the early 20th century or late 1800s, that I think early 20th century, that it was identified as the the remnant of that explosion. It's also one of the there is a neutron star in the middle, a pulsar, the remnant of the star, and it's one of the few pulsars that has an optical component that you can measure, that has been measured with telescopes, and it's also very yeah, and it's an X-ray source. It's broadcasting at a lot of different frequencies. The debris field is expanding at about, yeah, so here it is. It's very faint because it's really close to the horizon, but normally it looks like, here's the view in stellarium of what it looks like. The outer layers are expanding at 0.5% of the speed of light. So it's moving pretty rapidly, the outer layers, and we've imaged it long enough that there are animations of it expanding out there, so you can see it kind of slowly moving the outer layers. But unfortunately, it might be just too low on the horizon for it to give a good image. Didn't even have, yeah, I know how that is. Go through the whole setup process. Yeah, Crab Nebula. Yeah, unfortunately, this is kind of not my best Crab Nebula, so we'll move on to the next target. So again, this was 1,000-fold jump in distance. Now, the next one isn't going to be as much of a jump. And I debated, actually, maybe I'll do another one. Yeah, let's try that. So this won't be as much of a jump, but I'll stop that, and we will go on to the next one. Now this one's a little bit more tricky, but still kind of cool. Do I have my gain cranked up? No, I think I'm still at 80 on this one. I should probably increase it a bit. Especially with the moon the way it is tonight. Hopefully this'll work. Hopefully it's not obstructed. Oh, it finished plate solving. There we go. So the next thing on our journey outward is a globular cluster, specifically one of the brightest apparent globular cluster in the sky, Omega Centauri. Now, Omega Centauri is about 15,000 light years away, so the way we're seeing it is the light we're seeing from it was emitted during the last ice age. Now, it's even so, it's only about not quite 3 times as far away as the Crab Nebula. So we didn't do a huge jump here. But it's still kind of interesting because a lot of these globular clusters are actually kind of out of the plane of the Milky Way. They're actually orbiting the Milky Way, but they're not within the disk of the Milky Way. So it's kind of an interesting type of object, and it's a particularly nice one, and it's hard to image in the northern hemisphere. It's very far south, so unless you're in more the southern part of the United States, and of course it's the southern hemisphere, it's high in the sky. Here right now it's only about 8 degrees above the horizon at where the telescope is located, and I would be very hard pressed to image that from my house, just because it would be behind buildings. So I'm just going to let that accumulate for a brief moment, while I'm also looking at my other scope, or one of the other scopes, I should say. Yeah, that's what I'll do. I will do that. Yeah. Yeah, painful reminder. Yep, exactly. Yeah. Yeah, well, and we're just getting going here. Oh, nice. Nice. First visual one. That's awesome. Let me, I don't want to, so after I'm kind of done with the initial kind of plan for the evening, as far as which targets I'm going to image, I'm Probably going to image some other things from Starfront and probably keep it running, because trying to take advantage of the clear skies, even if the moon is interfering with things. Oh shoot. Okay. Yeah, that's a great question, and yes, it's because it's so low in the sky. I'm imaging through tons of atmosphere. Let's see if this works. Oh, hey. Did not. Let me... Is it pointing at the right spot? Hold on a second. Let's see if this works. I'm doing something off camera that will become apparent shortly. And all right. Cool. So So, oh, do I have clouds here? I'm looking at my all sky camera below. Let me make sure I am. Okay. So I'm gonna bring on another thing. So this is from my refractor, which if you're on one of the non vertical streams. Yeah, lots of reds and blues, yeah. So this is Omega Centauri. Yeah, it's nice having yeah, and welcome Star Traveler. How's it going? Thanks for joining. Yeah, they don't Yeah, old, and they, like, a lot of globular clusters are pretty old. They don't really have nebulosity. So yeah, nice rain shower, cool. Sky threatening to clear up. So so that's Omega Centauri, and on the refractor, I went ahead just to put it to use. It looks pretty puny compared to Omega Centauri, but this is also, it is a, but so this is M3, Messier 3, which is another globular cluster. It's actually about twice as far from us as Omega Centauri is. So it's not, so it's 33,000 miles away. So the light we're seeing from it is from before humans, probably from before humans got to the Americas. So this would be like a 5-fold jump from that's what it's a 5-fold jump from the Crab Nebula. This particular globular, whereas and the exposure is done for Omega Centauri. What's impressive is even with the live preview on the Seestar, you can really see Omega Centauri. Yeah, they might be. So funny you should mention that. Because our next target so let's see how that is. Okay, cool. So I'm going to switch over to M3. Now, M3, we're going to revisit that in a bit for reasons that will become clear later. But for now, we're just focusing on M3, or we're looking at M3 here, while the other Seestar at Starfront is going to the next target. So the next jump isn't. It is interesting because when you look at things in the solar system, I mean, there are comets far out from the sun in the Oort cloud. But when you're talking about the planets or even some of these dwarf planets, that next jump out to even some of the nearest stars is like thousands of fold. But then as we were kind of going through the galaxy, it's, you know, tens of tenfold or just a few fold jump difference in distance. So this next one we're imaging is it's, I know Cosmic Ray hates this one. I shouldn't say he hates it. It's just, so this is, I've imaged some of these previously, but on different streams, but this is the bright star Regulus. And if we look up here, unfortunately it's not as visible on a night like tonight, but we'll let it go for a little bit. But in here, you'll start seeing some stars show up, assuming we don't drop a lot of frames in here. Now you can see galaxy over here. That one is IC 591, and I think it's fairly far, but that's not what we're looking for. We're looking for you can start seeing it here. I don't know how well it comes through on YouTube, but there's kind of a discolored area here. It's kind of really subtle. It's like a faint fuzzy. And yeah, hold on a second here. Oops. All right. Let's see. Yeah, give me a moment here. Okay, cool. Nope. Not that. Give me a sec. All right. Yeah, unfortunately, the moon is causing a little bit of extra difficulty. But kind of in the interest of kind of showing you what we're looking for here. So if I zoom out here, yeah, see, we're dealing with some major gradient here. So this is what we would see on a clear night, and it's kind of starting to come through here. Like, you could probably get it with some either more time or processing. But what that is, you can see it here pretty clearly. Yeah, and this was like 20 minutes. So maybe after 20 minutes we'll see it. You think it might be an artifact from Regulus, but it's actually sometimes it's called the Regulus Dwarf galaxy, and other times it's called Leo 1 because it's in the constellation Leo. But this is actually a satellite of the Milky Way. It's actually possibly one of the furthest satellites. So Regulus itself here is 79 light years away. But that dwarf galaxy, this little smudge here, is 820,000 light years away. So that is like a 40-fold jump from Omega Centauri, or 20-fold jump from M3. And so this, you could argue, is one of the more distant things that would be part of our galaxy. So excluding comets, Haumeas, there probably will be much more distant dwarf planets found, but it's pretty distant from the sun as far as non-comet bodies go. Now, Leo 1 is about as far away from our galaxy, from the galaxy as you can get, while still being part of the, you know, orbiting the galaxy. So that's where, so now we've gone through solar system and Milky Way, and now we're going to go on to galaxies. I might skip one of these, but yeah, you can start seeing the smudge a bit here, right in here. Again, I don't know how well it shows up in YouTube, but I can kind of see it here. It's really faint, mostly because of the gradient from the moon. Australopithecus, yeah. Do we know the distance of objects or use redshift? Cepheids at this scale, yeah. Cepheid variable is the name of sci-fi club. Nice. Looks like a fuzzy patch, yeah. Yeah, M51 is M101 is difficult. It's lower surface brightness. I've found that it needs a lot more time to get a good result. Yeah, Regulus is in Leo. Yeah. Yeah, I mean, like I say, I've gotten some images of M101 I've been happy with, but I did it from Starfront and it was like hours of data. Yeah, Messier missed that one. Yeah, so it's part of the local group, but it's believed to be part of a satellite of the Milky Way. Out of date again. I will fix that. I can help you with that, Hayden. Okay, cool. Yeah, so the other thing, 820,000 light years away. So we're seeing it from 820,000 years ago. So pre-Homo sapiens, pre-Neanderthals. I don't even know what hominids were around back then, but yeah. And yet this is still part of our galaxy. So let us go to, we're gonna go to one that I like. I mean, there's a lot of galaxies I like, but it's a fairly bright one. And I'm partly because of the moon, kind of causing problems tonight. I'm not gonna get too carried away with fainter targets at this point in the evening. Okay, so we will go all right, there. Can I even image this one? Okay, we'll try. So let me check the chat. I think you might be right. That might be when the monolith. Right. Yeah. No, that's cool. I mean, I'm intrigued by that one, but yeah, it's going to be a lot of data. there's a few other planetary nebula like that I've been wanting to image that it's just too hard. The file is inside the computer. Other two scopes on vacation. So I actually had, I'm still keeping the Messier 3 imaging. I'm not sure if, I'll have to see if it's, okay, is it starting? Okay, cool. It's starting. Finally starting, so. All right. And then the other one, actually, you know what I should do with the other one? Let's see if I can do that. Nice. That is an excellent point. So let me. Okay. Give me a moment here. Okay. Yeah, I should have, thanks for reminding me again, Cosmic Ray, because I should have really kicked off this one earlier. Let's see. Okay, cool. All right. All right, so let's go back. So here we have get some red to show. Cool. Yeah, a lot of data. Cough, cough, Mark. Current objects. So far, up till this point, they were not. Yeah, the local group of what do you call it? I mean the Milky Way and the Leo 1 satellite galaxy are part of the local group, but yeah, we haven't gotten. I can't image Andromeda right now, so instead I'm went to M81 and M82, which are further than Andromeda now. So this is like 12 million light years away. So pre-human, the light we're seeing from these galaxies. M81 is kind of a grand design spiral, and M82 is an irregular galaxy with a lot of I don't know why it's so yellow, but I guess it's just the stretch. Why do I hear where is the music not playing? Because that's actually when I'm listening to the spa music. Andromeda is part of the local group. Technically, it's Milky Way and Milky Way and Andromeda are the two main galaxies, and then there's all these like satellite galaxies, I think. So we've jumped again from the from that dwarf galaxy that's a satellite of the Milky Way to these galaxies which are beyond the local group, and that was a like a 15-fold jump. So not a huge jump compared to some of the other jumps, like when you go from the solar system to even the a nearby star, and even within the galaxy, you know, some of those jumps were 10, 20, and this is only 15-fold jump. And now, granted that Leo 1 is pretty far from it's a distant orbiting satellite of the Milky Way. Oh, hey, Dave. I just saw that, just saw you. Thanks for stopping by. Yeah, Sombrero's 29 million. Oh, right, Triangulum. I forgot Triangulum. Okay, cool. Thanks, Penny, for confirming that. But yeah, that's what I've been listening to. I've started doing that. I don't know why. My older live streams, I didn't have headphones on, but since I have the music going, we're collision course. So yeah, so here, these are pretty bright galaxies. Yeah, any day now. Yeah, I'm not probably sticking around for that. So these are pretty far, not that far away, but like I say, this was like a 15-fold jump in distance. Now, I think I'm going to skip the next one. I was going to go for NGC 5957, which is a galaxy. It's fairly small. It's about 100 million light years away, but there was a recent supernova there, and that would be like an 8-fold jump from these galaxies to that galaxy. But we're going to go further than that. We are going to go further than that. We'll just skip over that one. And let me go. That's still going. So I will stop this one, and we will move on to the next one. So again, this was 12 million light years away. So 12 million years ago is when those photons were emitted that are just now getting to the telescope. So next, we will go I know there's some people who are a huge fan of this one. And it's not a bad target either. Into Romulan territory. I thought Romulan territory was on the other side of the Milky Way, in like one of the other quadrants. Not that I would remember that. I'm sure there's some people who could tell me what quadrant it was. It wasn't the Delta Quadrant, was it? Well, according to the new track. Yes. I was just watching a clip from that the other day. Beta quadrant, maybe. I don't remember the quadrants. Let me pull this over here. Oops. Oh no, stop. Stop the madness. Okay. Oh, nice. Okay. So, okay, Delta is Voyager, Gamma is Deep Space Nine, Alpha and Beta. Okay, one full nerd. No, that's okay. We need accuracy here. You know, I'm trying to give everybody the best possible information, and we don't want to skip anything. So, this is Coma B, or the Coma cluster, which is 300 million light years away. So this was a jump 25-fold from the previous galaxies, M81 and M82. Who could participate in the next Sci-Fi Jeopardy? Exactly. So you can start seeing now, because of the distance, because it's 300 million light years away. These targets are very faint, or the galaxies are very faint and very small. Even in spite of some of them are very, very large. So let me see if I can find. Nope. So I went ahead and with the S30 I have running. So here's the third scope. This is running in my backyard. I went ahead and got it started on the Coma cluster. Now it's got a wider field of view, but can I zoom in? Yeah. So you can see some of the galaxies. It doesn't flag all of them because some of them are non-NGC, non-IC targets. Oh, hello, Misty. Welcome. Thanks for joining. Been lurking. Yeah, I appreciate, glad you're here. Thanks. Thanks for joining tonight, and not lurking or not, it all appreciate all the likes, subscribes, views. It's all good. Thank you. And like I say, glad to see you. So yeah, so this is the Coma B cluster. Now, Coma B, so it's 300 million light years away. So to put that in 300 million light years away. So to put that in frame, in in perspective, the light we're seeing from this is when Pangea existed on Earth, when all the continents were kind of connected to each other. So, yeah. Yeah. Before, the light we're seeing from these galaxies was emitted before the dinosaurs even existed on Earth. So, now the Coma B cluster is kind of, besides that, the fact that it's far away, it's interesting because there's over 1,000 galaxies that have been identified in the Coma cluster. And the Coma cluster itself is, there's another cluster not too far away in Leo cluster. Now, both of them are actually part of the same, the Coma supercluster, which is part of the CFA2 Great Wall, which is one of the largest structures in the universe, which is like hundreds of millions of light years long, I think. Or one of the largest structures we've seen in the universe. Now, yeah, and so then this is, like I was saying, about a 25-fold jump in distance from M81, M82. Now, the next jump won't be as far. I'm going to leave this one going on the Coma cluster for a while. This is Seestar S50 sitting in my backyard. And I've been able to do some pretty long exposures of the Coma cluster from here and gotten some reasonable results for it. But it's sometimes hard to tell, but there's a lot of these like little fuzzy type star things that are actually galaxies, like that and that and that. And of course these are the big ones, but and then there and there and there and there and there. There's like a few dozen. I was trying to find a photo. Let me see if I could find that. Is that it? Anyway, I had taken a photo of the Coma cluster and I had annotated all of it, and it was quite a few stars in it. I mean, galaxies in it. Yeah, anyway. So, all right. I see on the Discord server there was an earthquake in New Mexico. Near 5.3. Kind of towards near Carlsbad. Interesting. All right, so the Coma cluster. All right, so next we will go a slight jump not as big of a jump. I mean, we're 300 million light years out at this point. So let's go. Let's stop this and go image the next one. Now again, the problem is as you get further, the targets get smaller and fainter. So that, so like M81, M82, you know, they're decent size in the telescope. But like you go 25 times further and the galaxies in the Coma cluster all appear to be very small, when even though a lot of them are quite large, larger than M81 and M82. But because they are 25 times further away, they seem small. And so this is where you run into a problem once you start getting this far out. The objects that you can image, either they have to be either incredibly big and or just intrinsically very bright. And so this is where we will be heading. Okay, cool. So this was one that was suggested on a live stream, and it's a pretty good one. But again, it'll end up being like a faint fuzzy. But it is a galaxy that is, let me see, I think that's it. Oops. All right. And let's see. Yeah. So in here, you can kind of start seeing a bit of a smudge. Now, it's not going to be particularly large. It'll be about this big. But this is IC 1101, which is one of the largest galaxies. The different numbers have come out from different measurements, but it could be, I've seen numbers of over 1 million light years across. I've seen numbers, so basically it would be from here to that satellite of the Milky Way. It's so such a large galaxy. I've seen numbers lower than that. I've seen numbers higher than that. But it is a very large galaxy. And it is, so again, Coma cluster 300 million light years away. This is 1.2 billion light years away. So now we've gotten into we are like 1/10, and yet, so we're 1/10 of the way across the visible universe. So it's this thing in here. And again, it'll end up being kind of like an oval, yellow oval blob of light. Again, not too large. It doesn't appear very large, but it's intrinsically very, very large. And again, the light we're seeing from this was emitted over 1 billion years ago. So I don't even know what was going on Earth back then. You know, pre-Pangea. Is the stream going to end with your reveal of liquid nitrogen radio telescope? No, no cosmic background radiation tonight. But I do like that. I do like your thinking. Quake outside Midland. No, we broke into a parallel universe. Time is a flat circle. Penrose cyclical. Yeah, that is far out. It really is far out. So yeah, we're out to 1.1 billion light years away. This kind of, like I say, I'm not sure how it shows up on the stream, but hopefully it does. It's this like yellowish thing. Now the problem is we've already gotten so small as far as things that we're looking at, and dim, even in spite of this being an enormous galaxy. So subsequent things will be, so yeah, this is the 15th magnitude. The next target will be technically slightly brighter. So let's go ahead. Are you a leak from another universe? Yeah, I don't know. I like the one with, yeah, like where kind of universes sprout off of other universes, like from quantum. I don't know. It's been a while since I read some of that stuff. I mean, some of the theories. Okay, so I'm gonna stop this one, but hopefully you can see this. It's in here. It's this yellowish kind of, I mean, there's some stars in there, but it's this kind of yellowish oval. Now, so that is the most distant normal galaxy, or relatively normal galaxy we're going to look at. So on the list below, you see solar system, Milky Way, I haven't been updating this, so we were Milky Way, and then this is the last of the, not really last of the galaxies, but what I'm calling galaxies as far as things that are that take up an area. Like, they're not points of light. They cover some area on the sensor. So next we will try okay. So this one is actually slightly brighter. Slightly brighter. So now we are going from the land of galaxies to what I'm putting down as even further things. Technically, well, I'll get into it. I'm sure people know where this is going, but here, so this is going to be another one of these things of trying to find the spot. Oof. check the chat. Far out the simulation ends. Black hole, yeah. I don't know, it's the next object mail pouch, tobacco barn. Nice. Yeah. It's oh, hello Astro Chris. Welcome. Thanks for joining. We're still heading out of the universe. I mean, out towards the outer limits. Oh wait, not the outer limits. All right. So this is going to be another one of those tricky things. Okay, yeah. Actually, that's pretty easy. So if we zoom in here, and you see these stars here, right? And then you see this little triangle of stars here, right? Well, this is just a star, and that's just a star, but that's not a star. This thing right here is a quasar. Specifically, it's actually brighter than the 13th. It's like 12th magnitude. It's not that. It's fairly bright. It was actually the first quasar that was identified. Oh man, that's annoying. That's very annoying. I wonder what happened. YouTube can be weird like that. That happens to me. It happens to me often. I'll find out there was a stream after it's over. But yeah, that star right there. This one. Let me zoom in even more. So this thing right here, that is a quasar. It goes by the name 3C273. It is, so the galaxy we were looking at, IC 1101, is 1.2 billion light years away. This is 2.5 billion light years away. So even though it's much easier to see, it's actually twice as far. So we did another twofold jump. So at this point, we're like the light we're seeing from this was emitted when the Earth was half its current age. So pre-dinosaurs. I think even, I don't know if it was I think it was pre-multicellular life. It was a long time ago. It's very far away. Now, how is it we're able to see this? So quasars were first discovered in like late 50s, early 60s, where there were these star-like things, quasi-stellar objects. They looked like stars, but they had very high redshifts, and they realized that they were moving away at a high rate of speed, which meant, because of the Big Bang, that they were very far away. And, research has come out, they've been studied and theories have come out about them, but they're basically distant galaxies that we can't necessarily see, although you can't easily see. I know they've been able to image some of them since, but basically there's a massive black hole in the center that's emitting a lot of energy. Like there's a lot of mass going into them. It's a very active black hole. Now, sometimes it's just happenstance that the black hole, when matter falls into it, it'll sometimes create jets that'll go out kind of along like the poles or similar kind of idea. And it might be that a specific quasar, that jet is pointing more towards us, so it looks brighter than it would if it was offset a little bit more. That said, I think this particular quasar, which was the first that we identified and categorized, might be still one of the most intrinsically bright things in the universe that we've ever found, which is kind of cool. That this thing is so intensely bright. Yeah, Penrose is interesting. Leaving Crazy Hero Dungeon. Yeah. Interesting. So anyway, so that is a quasar. And it is 2 billion light years away. Now, again, I'm debating if I skip or I'll let that image for a moment while I look at something here. Oh. Oh. Yeah, unfortunately, that isn't. So here is, I've been letting M3 continue on. But, so this is interesting because it was not interesting, but I like that this was taken in my, this is using the light pollution filter I've been using recently. It seems to do a pretty good job, because this is in my backyard. Now down here you can see near M3, you can see this galaxy here. But that's not what we're going to look for. We're going to look for something else tonight. But I'm going to change the telescope at Starfront to point at this galaxy. So I'm going to stop this. Yeah, I'm going to skip over one of the targets that I was going to image. And so there are two more that I'm going to image. So we will go to NGC 5263. And we will get that going. And let me bring this back. And also, let me I mean, this is one thing I always find interesting is when you have these objects that you're used to seeing, like Messier 3, and then yet there's this galaxy, NGC 5263 nearby. And that galaxy is how far is that galaxy? It is 200 million light years away. So even though M3, Messier 3 is 33,000 miles away, or 33,000 light years away, this galaxy here is 10,000 times further away. Which is kind of cool. So again, even though it's like something, you know, you might have imaged or looked at, there can be all kinds of things lurking near the edges. Oh, interesting. Yeah, it'll be interesting if, because I know there's been different candidates for Planet 9, and then there was debate on, I mean, like the whole thing about, like, there were like anomalies in the position of certain outer solar system objects, like Uranus led to Neptune, and then there was a thought that there were some anomalies with Neptune, and so there was something further out, and they found Pluto, but then it was like that's too small to affect it, and then it's like, well, maybe there weren't anomalies, but then there's been other cases where there could be something further out. And there's been a few candidates that have come out over the years, but I haven't heard about the latest. But yeah, I mean, I'm trying to find the photo. I mean, I know I got a couple dozen, I think, from Starfront. But I'll have to look. Okay, so so here's that galaxy again that I'm imaging. Yeah. So we'll let this image for a little bit. I'm just trying to figure out the positions of different things and brightness of different things. Okay. Sorry, I'll look at the chat in a moment. I'm just trying to figure out the alignment. Okay. Okay. So let's zoom in on here a bit more. We'll be looking around this area. So the other thing that's interesting about these quasars, I forgot, there were things about them that didn't make a lot of sense initially when they were still trying to figure them out. So they were these things that were like stars, but they had these really high redshifts. And so it seemed like it was too bright to be a normal galaxy. The other thing is normal galaxies, you know, they emit light, and the light is kind of about the same over fairly long periods of time. Every once in a while you'll have a supernova, and that'll be brighter than the rest of the galaxy potentially. But even then, they don't fluctuate in brightness. Well, the problem is with some of these quasars, when they were first finding them, they vary in brightness a lot, or they can, and sometimes over a short period of time, almost like a variable star. Not like consistently variable, but they could fluctuate in brightness. So for it to fluctuate in brightness typically mean like that quickly would mean that it's small. Because even if it was like a shock wave going through something, you know, or some kind of wave going through a larger object, you know, you're limited by the speed of light. It can't change within a few days across an entire galaxy. So that meant the things were very, very small, very, very bright, and far away. And so that's how they kind of came up with the idea that it's active galactic nucleus, a galaxy, a massive black hole that's emitting a massive amount of energy. Another thing that was interesting about 3C273 is some of these, that one and a lot of the others, they just emit light across the electromagnetic spectrum. So you see them in visible, but they emit radio waves, they emit X-rays, they're just all over. So they're just like spraying tons of energy, all kinds of frequencies of photons all over the place. But you know, it's a supermassive black hole, so, but still kind of interesting as part of how they were trying to figure out what these things were, and they just longest single exposure. I mean, I've taken over days, 20, 30 hours on some galaxies, just trying to get some faint details from it. But I mean, some people get a lot more, and I'm hoping, like with the telescope at Starfront, that I'll be able to be, you know, do a lot more, like maybe 50 hours or 100 hours. Okay, so let's go back to this. That actually turns out pretty, I mean, given that this is in my backyard, this filter I'm super happy with. Like, there isn't much of a gradient here. I mean, I say that, but on the whole, it's not terrible, especially given that that's over an hour exposure and the moon is up, and I've got terrible light pollution. But like I can dim that a bit more depending on how it's lined up. Like I say, all things considered, I'm pretty happy with this one. All right. And the other thing that I've been letting go that I want to revisit here real quick is I've got 36 minutes of so far on the Coma cluster. Yeah, it's only plate solving 5 of them, but you can see a lot more in here. Like each of these are galaxies, but some of them don't have NGC numbers. And I know like at Starfront, some of them have catalog numbers that'll show up with plate solving, but all right, let me check the chat real quick. That would be interesting, because there's also like what do you call it, like the IFN, isn't it the Pleiades? Like there's the IFN around it. That would be cool. Yeah. Like if you get a lot on the Pleiades, you start getting kind of all this faint nebulosity around them. Okay. Let me go back to, let me look this up. All right. Okay, sorry. I'm looking for shapes and stuff and missing. Okay. So this star here is about the 16th magnitude. So what we're looking for is even fainter. It's about, but not like drastically fainter. It's about a magnitude fainter. And it should be right around here. Let's see if I can zoom in on that. Now, mind you, again, the moon is almost full. I mean, not full. The moon is quite bright. You can see it in the all-sky camera below. It's like, so it would be easier to get this on a clear night. I've managed to image this from home. I think that's it. Let me just double check. Yeah, okay. Yeah, so you've got kind of this shape here, right? That kind of goes like this. And then there's a few little faint stars here. each of those. Yeah. So that kind of shape I was mentioning, and then the faint stars, that one's 17th magnitude, which is the same brightness as this Q1337.8 plus 2832. It is, yeah, this thing right here. Let me see if I can. With this browser. Okay, cool. So right there at the tip of the mouse, if I circle it, you can see it's basically, so these 4 stars here are about 17th magnitude, and that right there is also about 17th magnitude. Let me just double check. Yeah, because if you draw a straight line between these stars, it's slightly to the left of it, about midway between these two. So that's it, this one right here. So one thing you start running into with these very distant, hold on a second. Yeah. The mini PC I have that I'm using for the live stacking is an 8-core. Okay, let me see. SH2313. Oh, nice. It's a pretty large planetary nebula. But it's an interesting one. It's the colors, and it's a pretty big one. I mean, like compared to, like in the Seestar, theoretically it would be pretty big. Winter native summer idea. Yeah. Doing recent. Yeah, yeah, I think mine is like an N305, the one that I'm using, that I was pegging the CPU earlier. Okay. Yeah, Lagoon. Yeah. Okay, so this dot there, that one that I mentioned was called Q13. I'll even put it in the chat just because it's such a, and mind you, this is like right near M3, Messier 3, near this little galaxy that's kind of tucked off to the corner. This galaxy is did I say? I think it was like 200 million light years away. And then these are just stars. that faint thing right there, that one, is a quasar. And quasars are measured by redshift. And that redshift is 2.5, which translates out to 11 billion light years away. The solar system's like 5 billion years old, so the sun didn't exist. The light we're seeing from there, the sun didn't exist. A lot of things didn't exist. So what you're seeing there is from the universe was less than 3 billion years old at that point. So things were, it was a lot different when those photons were emitted and the Seestar just picked up. Just that tiny little dot there. So 11 billion light years away. Now so the light has traveled 11 billion light years to get to our eyes. But meanwhile, the universe has continued to expand. And so there's this idea of the co-moving distance or something. Like basically how far away is it now from here? And a redshift of 2.517. The co-moving radial distance is almost 20, it's 19 billion light years away. So that's how far away it is right now. But yeah, those photons were, or it was slightly over 11 billion light years away. Yeah, vintage. They're vintage photons. But I'm not done yet. But wait, there's more. I'm not done yet. So we'll see if we can do something. Find another thing. Enhance. We'll keep going further. That wouldn't work. I was like, keep going back further until like you're looking back at yourself, but no, that wouldn't work. Looking back at yourself from. All right, so let me find one last target, and we'll see if we can get this tonight. All right. Alright, so we'll see how this goes. Meanwhile, let's look at the Coma cluster here. And let's look at this. This is starting to... Actually, I wonder at what point it's going to go behind a building here. still doing okay. Yeah, I think that this gradient will be a little tricky cleaning up, but so that quasar that I just pointed out, that's 11 billion light years away, it would be like right out of the frame. It would be right around here that we were looking at. So yeah. So right near Messier 3 is a little star that's not a star, that's 11 billion light years away. Yeah, those I want to image those as well. I haven't done it yet, but those look pretty cool. All right, so let's see. Okay. So we're doing. The interesting thing about this, yeah, it looks like it started vaping. Yep. What's interesting is we've gotten pretty far here, but there doesn't seem like there's a lot of, there might be some galaxies up here. Yeah, there's some galaxies in this photo, but that's not what we're looking for. But I think that might be a galaxy, or there might be some up here. Let's see. Okay. All right. Okay. All right. Okay, I think I've got my bearings a little bit. All right, it's 12th magnitude. Okay, so I've got these. Make sure I'm looking at the right spot. Okay. Unfortunately, searching through these star fields for a single star can be a bit tricky at times, to say the least. How bright is that one? Oh, that's not super bright. See, there's a galaxy right there. There's a few little galaxies in here. So I see these two stars, and then these two. Yeah. And then yeah, okay. And then these two bright stars. Okay. So I've got my bearings here. So we just need to keep zooming in on this area. Yeah, so those two bright ones. How bright is that star? Okay. I think that's 15th magnitude. And that's 16th magnitude. Oh, shoot. Forgot to plug in this laptop. That would have been unfortunate. Okay. Right. So we're getting closer. We're getting more data and a little closer to where we want to be. There we go. Okay. So like I say, that is a 16th magnitude star. And then that, yeah, okay. All right. Then a bright one, and then these two right here. Each of those is 16th magnitude as well. And then that is almost 17th magnitude. And so what we are looking for is, I think, somewhere in here. So let me check the chat. Yeah, I mean, yeah, that's one of the things. Like some of the brighter quasars, it's because the jet is basically pointing kind of generally towards the Milky Way, so that's why it appears as bright as it does. Yeah, that's exactly right. Yeah, I mean, I think the jets are brighter. So I know in some cases it's because the jets are pointed at us. Other cases it might just be spraying stuff every direction. So let me just check something here. we are... This is the last object on this kind of voyage, as it were. Let's see. Let me double check that I've got my coordinates correct. Oh. I might be slightly off, so give me a moment here. I mean, I'm in the... We're talking arc minutes, not even a low number of distance, so let me make sure I'm pointing at the right place. It's 2... Again, I'm striving for accuracy, so I want to make sure I'm actually pointing at the right thing. So after this is done, I'll probably image some other things, but for now, oh yeah. 15, 2, 3, 7, 7, 2. Is that right? Wait, no, that's not right. I ended up kind of pointing at the wrong... I don't think I'm pointing at the wrong thing, but let me just double check. So, 16, 143. And 15. Yeah, okay. Oh. Oh, 143.76 and 02.37.72. Okay. All right. Okay, yeah. So I was off by a few. So we've got those two here, and then those two, and then so kind of there, and then so these three here. What are those three? Okay. Okay, you've got. All right. And then that. Yeah. So let's see this. I'm just again wanting to make absolutely sure that I'm pointing at the right thing. And then let me look at the chat while so I don't, yeah. Okay, Omega Nebula. That's cool. Ah, from the disk itself. Yeah, what frequencies? All of them. Yeah, it turns out like 3C273 is actually pretty bright in the radio frequency, like even by Quazar standards. Because I remember seeing this like map of the full sky, and it had, you know, particularly bright radio sources. So it had like the sun, it had Jupiter, like the Milky Way core. But then it also had 3C273 as like a particularly bright spot in the sky in radio waves, which I was like, wow, that's impressive. That is very impressive. Yeah, I feel like I'm let me double check my bearings here. Okay. So we've got yeah, if it was 33 light years from Earth, it would be as bright as the sun. That is pretty impressive. That is super bright. Yeah. Yeah, I mean, invisible, but it would be emitting so much other stuff. It probably would not be a good time. It would be a really bad time. Okay, so, all right, so that's those, and that's that. So that's the other issue I've had with figuring out some of these things is like they'll have a list of the brightness, but it'll be like it'll be a different, like whatever frequency it's at, the Seestar might either be less or more sensitive. So sometimes I've even noticed it with images where things will be slightly off. Okay. Yeah. I feel like that should be brighter. Yeah, it's strange because I always have these issues, but not always, but a lot of times I'll have these issues of trying to chase down. And the problem is like these don't show up in catalogs, normal catalogs, you know? Like you can look it up, but it's usually it stops at IC or NGC, and then you sometimes get into these PGC objects for galaxies, but some of these you start digging around in like the Messier catalog of quasars, trying to find, and they don't necessarily show up on charts, or they're like wrong, the positions are wrong. Golly, give me a sec here. I need to take a break from looking at these, so I'll look at the chat. What's being close, or the line of fire of yeah, I don't know. A free creality. Oh, nice. I mean, to be honest, you're fried with either one of those. Oh, nice. Harmonic mount. That would be awesome. Yeah, exactly. Yeah, exactly. I think at some point it doesn't really matter. Like, those numbers are so large. And I think the other problem is with this, that when you start looking at some of these objects, they're like, because they're redshifted, some of the brightness is in the deeper red. So like this one is brighter in red and infrared. So the Seestar might not be optimal for imaging it, but I have imaged this one before, so we will see. because that's another issue I'll end up running into is some of these things are brighter. Okay, I think okay. Yep. So, see these two stars, they form like what do you call it? A quadrilateral. And then you've got this star here. Right here. That's not the star we're looking for. But that star right there is a star, and it is, let me double check that I'm looking at the right one. Yeah. So that is the 17th magnitude. This star right here. And then if you kind of draw a straight line between these two, and almost about as far away, you get another star, which you can kind of see right here. It's a little fainter than this one, but it's starting to show up. Again, if the moon weren't up, it would be a bit brighter, but you can see one there. There's actually yeah. Yeah, so you'll see there's a star there. And that star is, of course, not a star. It is a quasar with a very long name. Dang it. So this is the name of the quasar, and here is the page describing it. And it's just a survey page, just talking about like the stats of it. So it's this little one right here, which you can barely start making out, but it is, that particular one has a redshift of 6.699, which makes it 12.9 billion light years away. So these photons were emitted when the universe was only 800 million years old. I think the most distant galaxies that like James Webb has imaged are like 300 million, like that the universe is 300 million years old. So I mean, given that this is, you know, a Seestar in Texas, yeah, it unless we find a brighter quasar that's a little further away, you're not going to get much further than this. So some of the globular clusters we see didn't exist when those photons left. A lot of galaxies didn't exist. I don't even know if the like yeah. Yeah, I mean, the Milky Way had probably formed, but some of the globular clusters had not, and most other things had not formed when those photons left that that object, that quasar, and using that that co-moving distance. The last one was 11 billion light years away. Or it was 11 billion, and the co-moving distance is almost 19 billion, or over 19 billion light years. This one is 12.9 billion light years away. But the co-moving distance is 28 billion light years. So that object is now 28 billion light years away from us. But yeah, that little dot there. Those photons left that thing almost 13 billion years ago. More than twice as long ago as the age of the solar system. Yeah, so that's all I have for the for distant objects. So now we can move on to other things. Although I might get up and stretch my legs, since we have gone across the universe. I'll bring up, what was it, this Omega Nebula that Star Traveler posted. That is really cool. That is really, really cool. I need to take some image of that. I need to take an image of that. Anyway, so yeah. That is it's cloudy for yikes. Almost as old as I feel. Co-moving. Yeah, I think it's the co-moving radial distance is, oh man. But yeah, I think basically that, yeah, how far, like we moved away and it moved away, the photons got to us, but it had continued to move away and stuff, yeah. Amber, yeah. Oh, okay. It still looks really awesome. That looks really awesome. Definitely more impressive than this little dot. At least as far as, what do you call it? Kind of impact on how it looks. Let me look at, I want to check something here. Unrelated to the oh shoot. I'm going to stop that Messier 3 because I think it did the meridian flip. Yeah. That looks pretty cool. It'll be interesting to see what the gradient ends up. I think it meridian flipped. So I'm gonna stop that. And all right. Yeah, so we'll come up with another target, but I need to get up and stretch my legs. Nice, June 15th. Yeah. Yeah, I mean, I'll probably image that at some point. Maybe when the moon's out of the way. Because unfortunately it was cloudy, of course, around the new moon. And so, hopefully the weather I think the weather will settle down at Starfront. Like the spring tends to be more, these fronts come through and the weather ends up really volatile. Yeah, that would be cool. So yeah, I'm gonna stretch my legs real quick here for a moment. And yeah, so, and we will pick a couple other targets to round out the night, but that was basically the journey across the universe. Started with the moon and ended up with something almost 13 billion light years away. So that was, there's a few other things I was going to image, and there's some other quasars I want to image. Like there was one live stream I did where I did a twin quasar, and I'm kind of curious I want to try it again because I did it from home. I didn't do it from Starfront, and the SETI Astro tools might allow me to split it more easily. And then there's another one. There's what do you call it? Is it the parachute? It's like a quad lensed quasar, and I need to look at it to see if the individual components are far enough apart from each other that the Seestar could kind of not necessarily resolve them, but you could tell it's more than one object. But there's a few things like that I want to try. Yeah, no, thank you. I mean, I've imaged a bunch of these things in the past, some of them on live stream, some not, but I had this idea of like trying to, kind of do it sequentially just to see how far it would go. Now, the one thing that I didn't do that I want to do, and I might do it in a video, is Space Engine kind of lets you do simulations of and it does a lot of generative stuff, so you can look at, like, it'll make planets for you, but it has some real objects in it. And I know for some of the solar system and galaxy stuff, it has objects in there for some of these, and so I've been wanting to kind of combine them so you could kind of do a pan out, but I have to work out some details at the end. Yeah, should have zoomed in last object to face. Yeah, I mean, that would be funny. Yeah, or it kind of goes and looks like it's the cosmic background radiation, but it's like just the back of my head, and I turn around and like, what? Yeah, but one thing, oh, okay, thanks Qubits for joining. Good night. Yeah, one thing about that is it's the man behind the curtain. Exactly. I mean, the other thing that's, I think, is kind of cool is, and why I wanted to do it is, it's just I mean, not just, but it's a Seestar, and yet, like these things are within reach. Like a quasar that's like, yeah, the thing is that, like, there's a database, and they're always finding new quasars, so there might end up being one over 13 billion light years away that's within reach of the Seestar, but right now, when I looked in some of the databases, the ones that were further were like 25th magnitude or something like that. So I don't think it would be within reach of the Seestar. But anyway, yeah. So but yeah, I'll be right back. I'm just gonna stretch my legs, and like I say, I'm not gonna go for hours more, but I do want to kick off some things and try to take advantage of the skies at Starfront, even if the moon is up. I'll be right back. Okay, thanks Benji, for joining. Have a good rest of your night. All right. All right. All right. So, I've got, oh, let me turn that off. So I've got I've got one telescope, the Seestar, local Seestar is still imaging the Coma cluster. I'm just going to keep that going. But the refractor I've stopped, and now I stopped the refractor. So I am going to find something for that and for Starfront. Now, Starfront, let's see what would be a good target. Now, the problem is since the moon's up, that kind of constrains what I would want to image. Oh, let me see. Oops. I'm just looking off screen. I'm looking at Stellarium for things. Okay. Let's see, is that... Oh, those are small and faint. Okay, that would not be a good target for the Seestar. It's a few. Yeah, let me try that. Where is this in the sky? Yeah, that would be cool. Let's do that. Let me see, where is it relative to the moon, though? Okay, it's far enough away from the moon. Let me do this. Yeah, 200 pixels. I think the idea being that because normally with field rotation, you get a lot more movement. So even in spite of the dither, you get on top of that rotation. But when you're in equatorial mode, you don't have that, and so like there's this kind of, well, let me see, like to see this colored, this kind of mottled coloring on this image. It's not gradient, it's just kind of, I don't know. But yeah, the idea is that it would help reduce that. So let's see, this was 50 minutes, so let me stop this and we will go change the settings. So I'll dither every, I'll do every 10 frames. So that'll be since I'm doing 10-second exposures, it's every minute and a half or so. And then I'll turn this to 200. Yeah. So we'll go with this. And I will kick off do I want to kick off a autofocus? Yeah, the focus looks okay. So I will go, let me start that over here. So let's actually, is there, I'll just leave that. I'll just go with that. And let me look at the chat. Which camera does the Seestar, or it has, it's the S50 has the IMX 462. And the S30 has the 662. They're both like 2 megapixel color sensors. Yeah, yeah, clouds. Yeah, and hello Harsh, welcome. Thanks for joining. So we'll see how that goes. I do have it set to the 200 pixel dither. So we'll see. Yeah. Cool. All right. Oh. It's already. So every 10 frames it will dither. So we'll see how that ends up working. And what I need to try is find something, or what I want to do is find another target for the refractor. Hello, is Dream? What's the program? I mean, I'm using what do you call it? ALP, which is, I mean, it's the telescope is a Seestar, and I'm using open source software called ALP, Seestar ALP, which lets you control the Seestar, as opposed to the app, which I also have running on a different scope. This is a Seestar S50 that I'm imaging. A galaxy cluster. The galaxies are small, but yeah. But yeah, the program is called ALP. Yeah. I was imaging Mars early on the stream, and then that's when I noticed how close it was to the moon. But I didn't image the two next to each other. There we go. Oh, that's turning out well. There's a few galaxies in there. I see 4604. Oh. Is that what you're imaging now? Unfortunately, today I was not really looking at the live stream or the Discord stream much. Yeah, but is that what you're imaging right now, Jeff? Oh no, or was that a suggestion for me? So this is actually, so has it dithered? Should have dithered at least a couple times. Oh, okay. Although that is a good suggestion. I do, oh yeah, yes. Yeah, I need to, maybe I'll kick that off shortly. I'll let this run for a few minutes. Are you running your scope tonight at Starfront? So these two galaxies are, the thing I'm imaging is NGC 5566, which you can see is an interacting galaxy here. This is what it looks like, but how this one is curved. And you can kind of already see, it's starting to curve a bit. So that's cool. Yeah, actually, I like that. Veil Nebula. I don't know, is that up yet? It is really low, unfortunately. The veil is, it just rose a little bit ago. Oh wow, Mars and Beehive. Nice. Nice. Oh, that's cool. Yeah, unfortunately, I didn't get the... I noticed they were near each other, but they weren't in the same field. Yeah, actually, what I also need to do is... What can I image with the refractor? That is a weird name for a star. Hold on. Turtle Nebula, that's small. I have a feeling that's too low, but let me try this. Oh. I wonder if that's visible. Hold on a second. Let me check. check. Yeah, I'm afraid some of these might not be too visible because the because of trees and stuff. But this is actually looking kind of cool. This kind of interacting galaxy here. And the color modeling isn't as, it's different. It's not. So maybe it does help. Okay. Oh, nice. I will be able to image this. Cool. Perfect. Perfect. Let's see. Oh, wow, nice. My guiding was really good today for me. It was like half an arc second. Now it's 0.3, 0.5 arc seconds. Ooh. Let's wait for this to settle. Okay. So let me go start imaging. Okay, cool. Sorry, I'll be back. I haven't checked. I'll check the chat in a moment. Sorry, I'm thinking about live stacking and all right. Let me check the chat. Huh. Yeah, I mean, the 2600 can be kind of expensive. Okay, the Starfront All Sky. Let me check. Wow, a lot of people are... There's a lot going on. I need to pull this in. I'll move this to the side and yeah, Wiley's site has M3 going on. Wait, hate that when I do that. here. Okay, there it is. There's the option. There's the option. Okay. Oh, nice. It's looking nice. Sunset in New Zealand. And the moon. And then we've got the Starfront all-sky camera. That's cool. Oops. Oh, that's cool. You got it from earlier. From twilight through and the moon's getting low. It'd be nice once it's out of the way. So let me see. All right. Okay. So I mean, it's just trying a different target. But on the refractor running here in Houston, I'm imaging the Ring Nebula. It actually doesn't look too bad. All things considered. I mean, it's a fairly wide angle scope, so I'm zoomed in quite a bit. I'm actually quite happy with that, all things considered. That's cool with the time lapse. Just as the cloud comes past. Yeah, I saw that when I had pulled it up and like some clouds came by. So which setup? I've got like a few different setups, and plus, so we've got we got too much. No, not too much. So I've got three, mostly it's Seestar. So in New Zealand, it's a Seestar S50. That's Destin's Wiley site has an S50 imaging M3. But yeah, as far as what I have an S30, an S50 running at Starfront, which is what I'm using to image these two interacting galaxies. That's the all-sky camera below the with the moon visible there. That's a Seestar S50. Every once in a while I show this. This is the a Seestar S30 that's running here in my backyard, looking at the Coma cluster, and then this scope here is a refractor. It's the one you can see in the all sky camera. So like there's two all sky cameras, one local, one at a remote observatory. So this is just a 75 millimeter Petzval refractor, Petzval design refractor, with an SV SV240 filter. So it's got some light pollution stuff. And I'm pretty happy with this. I'm really happy with this filter. 'Cause like, yeah, I mean, yeah, the colors, yeah, yeah, you should probably try that with that. 'Cause, I mean, it's basically dual yeah, that would make sense. Because this is basically a dual narrowband filter plus IR. So, yeah, time traveling. Yeah, the across the universe stuff was mostly done with the S50. Yeah. I'm happy with that. Actually turned out better than I expected, so that's always good. And this is turning out reasonable. And let me bring back Discord. I do like the time lapse. The moon is getting so close to being out of the way. Actually, let me see, can I didn't bring it on before, but let me bring it on here. I still need to figure out how to deal with the chat. Because, yeah. Actually, that's looking pretty good, this interacting galaxy. Doesn't seem to have the same kind of mottled noise, does it? How long has it been running? 18 minutes. Doesn't seem too bad. All right, so let us see. Actually, yeah. I mean, that background is darker than I would have expected. So what are you imaging at Starfront, Jeff? Oof. Why did it go pink? That's an odd color shift. Oh, that's weird. It's weird. That's a really weird color shift it did. Oh. I wonder if somebody turned on a light or something. Somebody turned on a light. Oh well. I'll move this off and I will pick a different target. Okay, 200 pixels. Yeah. Yeah, I think. Yeah, exactly. Who knows? Hopefully not. Let's see. That one. All right. Okay. Thanks. Good night, Jeff. Have a good night. that's doing. Let's see. That's actually turning out pretty well. I wonder if it's because the moon's getting lower, or if there's something about the dithering that's helping. I don't know. Let's see. All right. Sorry, I'm just looking at something off screen. Yeah, I'm not sure about that one. So let's see, 7023. That is actually turning out really well. Again, I don't know if it's that the new dithering option is helping. I don't know. It's kind of cool because you can definitely see the curve in that one galaxy from interacting. Hopefully this will end up a little bit better than the last one. Galaxies turning out nicely, but I do think I might move on to that other target that Jeff mentioned. It was IC 6404. Yeah. Let me try that. So that's looking good. Let's see. So I will stop this here. And then I will go image. I'll do an hour, and I'll do an autofocus. We'll see if that actually works. See where that it's getting a failure, but maybe it's... No, it should be up. So that is... Am I looking at the right time? Yeah, it's not super low. After the next plate's off, it'll... Alright. Okay. Alright, so let's try. I'm trying it again without the plate solve. I mean, without the filter, sorry. So weird that it's failing the plate solve. Let's see why. I don't know. For whatever reason, it's having a hard time with that one. So let's try something else. Although, let me, before I do, let me see the state of this. It's still going. Although at some point, it'll stop because it will go behind a building. So let's see, that galaxy was kind of cool. Let's see. So one thing is the Milky Way is up. So I just need to figure out what I would want to image on it. So many targets. what's that? All right, let's see. Maybe I'll do this, just to do something a little different. So it's something that's a nebula, but I'm gonna try it without the light pollution filter. Alright. Oh, there we go. It's already starting to get something. Yeah, on the refractor I was trying to get the Iris Nebula, but I'm not sure about that. So I'm gonna try something else. If this is just failing over and over again. Looks like it might be. Yeah. I think it's pointing at a building now. So let's find another target for the refractor. Yeah, some of that Milky Way stuff is just starting to get over buildings here. this is cool. I may keep imaging some stuff even locally pretty late, because now there's some Milky Way stuff starting to rise. Okay. Yeah, it might be getting close. Let me see how far that is. Unfortunately, the Trifid it's behind a particularly bad chunk of house, and it's pretty low, so it's not until like after 4 in the morning that it's kind of briefly visible, unfortunately, from here at least. Yeah, I definitely can get it from Starfront. Although, let me see, is it? Yeah, theoretically it's 20 degrees above the horizon here right now. And it's to the southeast, so I should be able to image it. Maybe I'll go ahead and go with that. Maybe I'll let that run for a while. Let's see. I'll do 90 minutes on this, and I'll just let it go. Oh yeah, definitely. I agree. It's a very nice one. And that's what I'm trying to figure out for the refractor, to see what I possibly could get imaging. Yeah, there's some little bits of nebulosity. Wow, that already got 20 seconds in, and it's already mean, so the headphone nebula, I mean, it's pretty good. I mean, that's another fairly faint planetary nebula. So, I mean, you got a pretty good, a reasonable result. Yeah. No, I mean, that's a good result, I think. Let's see. Yeah. No, I could see that. I mean, I've heard that people talking about other planetary nebulas like that, where they said it was a huge pain trying to bring out the detail. Well, let's see. Okay, so yeah, that I could see that. At some point I'm going to process some of those, or I mean, get more time on those. Let's see. Okay, let's see if I can get this. Yeah. Yeah, I should at some point. I probably will. I mean, especially once it's kind of up a little higher and a new moon. That would be cool to do that. See, I see. I don't know if this will work, but I'm gonna try it. Let us see. Hopefully it's not obstructed, but I'll find out shortly. No, I see stars. Could it be visible? Nice. Yeah, hopefully nobody shines a bright light into my camera again. Yeah, that's turning out nice. Four minutes. Not bad. this again. Alright. Yeah, because sometimes it... Sometimes SharpCap ends up a little confused, I think. Okay. Looks like it's... I have, but it's been not recently, but I have. Are you getting it with your refractor in Houston? Trifid? Or are you talking about something else? Sorry, I'm not. My brain's not quite there yet. Oh, interesting. Huh. The guide scope is seeing an obstruction, but the main scope is not, which is good. Let's see, or at least I don't think it is, but we shall find out shortly. It's a different target I'm imaging. Oh, okay. Interesting. No, I haven't tried that. I should. I should. What is the weather looking like here locally? Looks pretty clear. Yeah, I don't think I've ever used that feature of Telescopius. Hold on a second. That's interesting. I'll have to look at that. I think I looked at it for mosaics at one point. I think briefly. This isn't looking for something that's a little less subtle. That is really weird. What is this one? Wonder if I can get this. That might be too ambitious. Let me try that. Okay. Well, good night, Star Traveler. Thanks for joining. Have a good rest of your evening. And see you later. Oh man, my neck, I feel like it's getting a bit stiff. Yeah, that Trifid is looking pretty good. Okay, I don't think that is. Stop that because that is too low. That's not visible either. I'm trying, because the Milky Way is kind of it's now from Starfront it's easy, but from my backyard there's certain bits where the Milky Way is visible, the summer Milky Way, and the problem is I'm like the bits that I want to try to image are really low, and it turns out some of them are behind, still too low. Yeah, there's a few things that are almost there, but not quite. Let me try that. Just looking for targets for the refractor. Oh, and the Coma cluster, I stopped that with a Seestar S50 locally because it's now it had gone behind a building, so I should probably just park that one. All right, will this be visible or not? Yep, I see stars. That's a good thing. I see a star field, and it plate solved, and it adjusted itself by about 1/2 degree. That Triffid is looking really nice. I'm going to have to kick off a few targets at Starfront and let them run now that the moon is kind of a little more out of the way. Oops, did not mean to do that. All right. Let's try reset. So I did manage to start imaging the Crescent Nebula from with the refractor. So I will probably let that go for a bit. But yeah, speaking of a bit, I am thinking of, well, let me see. Yeah, I'm thinking of, wait a second. Yeah, I'm thinking of calling it a night. I was just looking at the weather forecast. It looks like tomorrow night it'll be clear here, but not at Starfront. I probably won't live stream tomorrow night, Sunday night. It does look like it'll be cloudy for a couple days, but then Tuesday, Wednesday, Thursday are looking clear at Starfront. So if that holds, I might live stream again on Tuesday. But yeah, thanks everybody for joining. I think that's it for tonight. Thanks for Turf for sharing his moon image early on. Thanks to Jeff and Wiley Sight and Destin for sharing their scopes. I can see down below Destin has started imaging C80. I believe that's another of the southern hemisphere globular clusters. So if you want to check that out, definitely go look at it on the Discord server. And I think, oh, it is. My bad. It is Omega Centauri, which I was imaging earlier. But it's super low in my sky, so Destin's will be much better. But I think I'm gonna call it a night. It is after 2 a.m., so thanks everybody for joining. And like I say, keep an eye out for the next live stream on Tuesday, probably. Yeah, good night. And I will see you in the next one. Let's see if this works. Thanks.